This is a 3D printed version of the chassis that I ran a successful Kickstarter for. And here we have the final version made of steel, powder coated with some 3D printed components. In this video I will show you how I went from this very light and small prototype to this final version that was shipped to my Kickstarter backers, plus a financial summary to see if it was worth it. The chassis I'm showing you here is based on open robotic platform concept, which uses design rules to standardize the components and make them reusable between the chassis. So I can easily use the components on this one, or even a huge chassis like this one, because the grid pattern is uniform and exactly the same on all plates. And it does not have to be circular. You can design a plate that is rectangular or pretty much any shape you want, as long as the grid pattern is the same. And now I will show you how I manufactured this steel robotic chassis, and I hope you will enjoy it. That's the design of 3D printed version, very thick plates, not well optimized for 3D printing part. It was all fixed with a new redesign, thinner plates, better optimized parts. There was a lot of changes, and normally I would order a small quantity of steel plates just to test them. But since I have quite a lot of experience with laser cutting steel plates, because I made a lot of them for Indie Mill CNC, I just ordered 300 plates without any prototyping. That could have been a mistake, but it wasn't. That right here is 200 motors. I haven't seen so many motors in one place in my life. All these motors will let me make 100 kits of the chassis, and while I have been waiting for the steel plates to be manufactured, I focused on redesigning the 3D printed parts. I started with motor holders, that's the old one, that's the new one. It is not only faster to print, but also way stronger. I also had to redesign the plate connectors and a few different parts. So I have been doing that and printing the prototypes and printing the parts already for production while waiting for the steel plates. When the plates finally arrived, we cleaned all of them with my dad. Unfortunately, powder coating that on my own takes way too much time, but I found a company close to me that is doing a very good job, so I just gave them the plates, and after 2 weeks... That's what I got yesterday, the plates for the chassis finally. The bottom one is matte black with this nice texture. That's another bottom one, and here we have the yellow color and the orange color. So the plan is that each chassis there will be 2 different versions, and each one we have the bottom plate black and then 2 of the orange plates or 2 of the yellow plates. I should also post an update on Kickstarter because there was none for a very long time. If you are curious why I'm wearing a hat indoors, my hair is terrible and I thought this is the easiest way to fix it, so that's what I did. Prints came out quite nicely and are pretty fast to print. I put in place the nuts and now I'm fixing that to the plates. That is pretty strong and also looks very nice, maybe even better than the circular connectors. When I had all of the new parts designed, I did a final assembly in Fusion 360 to make sure that everything is as perfect as it can be, and then I assembled the physical model with all the parts to make sure that it just simply works together after printing, and then I moved on to production. For the chassis there was actually quite a lot of 3D printed parts, and to print all of them I used my Bumbleup printers, the A1 Mini and X1 Carbon, which works great. I can just pack as many parts as I can onto the printing bed, and it works every single time pretty much without any failed prints at all. And speaking of failed prints, I had a lot of problems with printing with flexible filament because it was either sticking too well to the build plate or not sticking at all. So there was a lot of failed tires that I printed. Sometimes in the comments people ask me, Nikodem, what desk are you using? And I'm not joking, they really do. It's a good moment to tell you more about this desk with the sponsor of this video, FlexiSpot. FlexiSpot is manufacturing high quality electric standing desks. That means that with a press of the button you can go from sitting mode to standing mode without any effort at all. They have a very cool display where you can change the position of your desk and save the positions, which make it very easy to use later. The desk is very high quality, it uses 2 motors, it's very sturdy even with my heavy setup. I truly like this desk. Their website have a very nice configurator where you can configure your desk as you like it. You can choose between different materials for the desk, different sizes, colors of the frame, and plenty of accessories. The accessories I like the most are the ones for organizing the cables, because it can get a bit tricky with a standing desk But thanks to their accessories, it's very easy to do it properly and in a clean way. If you are looking for a new desk, it might be a good option to check out FlexiSpot. They currently have some sales at the end of the year, so check out the link in the description, go to their website. Remember that supporting the sponsor of this video means also supporting this channel, so thank you very much for that. Thanks to FlexiSpot for sponsoring, and now back to 3D printing. Here I'm printing the wheels, and these are all the wheels without the tire. And now I'm printing the tires, and this is seriously a big problem because these are flexible printed with TPU. And the TPU, the material, sticked way too well to bumble ups, to both my bumble ups, and I was just simply not able to take it off the build plate. It was very hard and I destroyed a few wheels that way. So I'm printing that on the FL Sun, and still the TPU sticks so well that it's hard to take it off, but at least it's possible without destroying the wheel. And I have like 50 of these wheels ready, of the tires ready, and I need 30 more just to fulfill the Kickstarter orders. And here I have all detailed prints, and now I tried to print some of the tires on the glass surface because I thought it will be easy to detach, and yes, it's easy to detach even during the print, so that's why this failed. I don't have AC there, and when you print on the Bumble Up X1 Carbon right here, it is an enclosed printer, and when these doors are closed and the top is closed too, it gets very hot inside, especially the temperature right here is already very hot. So I have to keep the doors open or the top open in order to keep the inside a bit colder, because otherwise the PLA gets a bit too flexible inside the extruder and it gets stuck. So I had to clean the extruder already 2 times, and I'm not printing with the enclosed printer when it is very hot in this room. Other than that, almost ready for shipping. Here's what I'm doing now, connecting the tires and wheels together and assembling everything with screws. Here are the wheels that are already ready, and here is what I still have to do. It's a lot of work, it's a lot of cleaning of the TPU parts. Here's the stencil. It took literally half an hour to print, just 1 mm thick. You put it on the box, and then with a little bit of spray paint, you have the RP logo. So now I'm putting in plastic bags all the 3D printed parts for this chassis, because this will be a DIY kit. The connectors with the logo, motor holders, wheels and the casters, all of that has to be in the plastic bag. 14 elements in total, and there are 40 kits to make for the Kickstarter, but in total I have parts for 100 robots, so that's a lot of work and it's gonna take all the time. I was aware that I know how to assemble it because I designed it all, but it won't be a case for the client, so in Canva I designed a very simple leaflet that was added to each box to clarify how to assemble it, and I just printed it on a normal 2D printer. All I have to do now is to grab a box with, of course, RP logo on it, and then put inside the plates, the screws, 3D printed parts, and with some bubble wrap and this paper thing protect it during shipping, and of course do not forget about the instruction. So in the end, was it worth it? Well, when it comes to the knowledge gained and the experience, definitely. It was a lot of fun also. But when it comes to the money, well, I think I underestimated the work that was needed to actually create all of that, pack it, send it, and also underpriced the product. But how much exactly did I underprice the product? Let's look at the numbers. So the revenue from the Kickstarter was 1,500 euros, that was pledges, and then 500 euros in shipping, and that was all the revenue. And then look at the costs. So we have the prototype, it was just 10 euros, I made it on my own. Steel plates was about 350 euros, powder coating 250 euros, screws about 60, motors 150 euros, and then 3D printing including filament, electricity and just using the printers 90 euros, packaging, that is boxing and all the filling to the packages 70 euros, and shipping 650 50 euros. So in total, yes, I didn't lose money on this project, but as you can see, the margin is not high, and actually instead of 40, I made 100 of these kits to sell some in my store, and I still have them, so if you would like to buy yourself an ORP chassis kit, there will be a link in the description. It was a lot of fun, as I said, and I enjoyed it. I created, I think, a pretty good product. If you would like to buy it, there's a link in the description to my store at industry.cc. And if you want to check out Open Robotic platform, there will be a link in the description too. You can upload your own parts, you can download parts created by other users, and you don't even have to register. You can do all of that completely for free. Thank you very much for watching this video, and see you in the next one. Bye.